This is a quick introduction to breadboarding. Important to first go over what's inside the actual breadboard. Here is a quick schematic representation where you can see that the horizontal connections over here are made with a single horizontal piece of metal. So we call these buses or rails, and they're often used for power. The vertical connections, or rows, are used to connect components together. So to get started, you want to make sure you have everything you need. Gather all the necessary supplies, including the components that you need, a complete schematic, the breadboard itself, some wire strippers, wire cutters, a highlighter, and not pictured but useful is a plier. You want to start by placing your dual inline package integrated circuits at appropriate locations. Here's a zoom-in picture of what's going on, and always make sure that pin 1 is in the bottom left of the screen of the breadboard. This will make sure that we've got a consistent way to debug what's going on, because the pin numbers might map to different component behaviors for other packages that we use in this class. Next, you're going to want to start making connections. So to do that, you're going to have to strip off about 1 centimeter from a piece of wire, as shown. Once you have that stripped off, you can place it where it needs to go. I know that there's a ground connection that needs to go into pin 1 over here. So I place it as close as possible to my ground bus over here. So that's why it went right in there. And then I'm just going to make a little mark with my fingernail right over there to measure where the jumper should go. Next, cut about 1 centimeter past the mark. Strip off that centimeter. Bend with pliers, and you've got yourself a perfectly short jumper or connection. Last thing you do here is you highlight the connection you just made. Here's another example where I highlight the connection I made here, and note the color code. I'm using red for my power, or 9 volts, high voltage, and I'm using black for ground. Don't use red or black for anything other than power or ground, respectively. Continuing to go, highlighting as I go. You can place your components like so, either just on one side of the breadboard like that, but if you rotate it the other way, you'd short all the pins of the potentiometer together. So keep the potentiometer oriented that way. You can add components directly to the buses or between rails. You don't need to use wires all of the time. And here's just a few more examples of other components. Try to keep them trimmed so that they're flush against the board. And over here, I've put a single wire with 1 bend in it because that's less prone to error. If I use 2 wires, that's an additional point of failure. Continuing to go, you might have to make some changes with where you place individual components, adding more things. Note that I'm using blue for all of my different signals. It's my non-power or ground color in this build. Here's another little trick. You can bend your component into a U shape as shown, trim it, and then put it directly into the breadboard, and that will save you a little bit of space if you wanted to connect a component between 2 adjacent rows. I'm also trimming my resistors here, as you'll notice. That makes things a lot easier and minimizes shorts. Continuing to build more parts of my circuit. Adding in the transistors. You don't need to trim these down. I just had a few that happen to be pre-trimmed. You can leave those upright because we use those transistors for a lot of different projects, so you might need them a little bit longer in the future. Continuing to build. Continuing to build. I bent my LEDs away from my face because they get quite bright, and while testing I didn't want to blind myself, but you can leave them pointing up if you wish. Adding a few more power connections, some signals. And then finally I added my switch off to the side, and it's a little bit hard to see, but I'm using a power supply to run this right now. It's always important to test with the power supply before you test with the battery. All right. So that should be my complete build. Highlighted everything I've built. So here you can see I'm about to test this, and as I turn the potentiometer, it should get dimmer or brighter. But as I turn the potentiometer, nothing happens. This circuit did not work. So, advance to the next slide. Here we can try to take a look at and figure out what's wrong with the circuit. And we have a lot of different components here to try to debug. It can be hard just looking at this to see what's wrong and what's working. But if we zoom in a little bit, but here's the problem. We can see a lot more to a pin called threshold. And you've probably seen it. So if we try to fix that, we can add in a little wire here. I've done it in green. But it's really bad practice to put a wire over the chip because it makes the chip hard to replace. So instead, just route a wire around the chip as shown. Now let's see if that worked. And there you go. That's how your final flashlight should work. Last but not least, here's a quick little final picture of the breadboard. So this shows you a nice, complete, and compact layout. Let us know if you have any questions. Thank you.